Hi everybody. In this video, we're going to look at how to differentiate sin x and cos x using the chain rule. And if you want to work along with me, you can download this PDF from my website. I'll leave a link below. So we've been given that the derivative with respect to x of sin x is cos x, and the derivative of cos x is negative sin x. In a future video, I'll show you how to prove each of these from first principles. In this video, we're just going to use them. So for question A, we need to differentiate with respect to x cos 2x. So we want to find dy by dx. The problem we have is that we've been given the cos of 2x, and our derivatives only work for 1x. So we need to use something called the chain rule. If we let t equal 2x, then we can rewrite this as y equals cos t. Now all we need to do is we can replace this x with a t. So dy by dt will be negative sine t. But we don't want dy by dt. We want dy by dx. So what we can do is we can multiply dy by dt by dx. And then these dt's will cancel. This is the chain rule. So dy by dx will be dy by dt, which we know is negative sine t. Now we need to work out dt by dx. But this is really easy. We just need to differentiate t with respect to x. So dt by dx will just be 2. Then we can substitute this 2 into here. So we'll have negative sine t multiplied by 2. And we know that this t is for 2x. So we can write this as negative 2 sine 2x. Okay? So that's how we can differentiate y equals cos 2x. There's a really simple pattern to this. All we need to do is differentiate the bigger function and then multiply that by the derivative of the inner function. So we don't need to go through this process every time. So for question B, we need to work out dy by dx. So using the same idea, the derivative of sine is cos. So dy by dx will be cos of that same angle multiplied by the derivative of that angle with respect to x. And the derivative of x plus 1 with respect to x is just 1. So dy by dx will just be cos of x plus 1. And for question C, we need to work out dy by dx. When we differentiate the sign, we get cos of the same angle 3x. And then we need to multiply this by the derivative of the 3x. So we multiply it by 3. Minus 2. The derivative of cos is negative sine of that angle multiplied by the derivative of x over 2, so multiplied by 1/2. And then you can see that this negative and this negative will make a positive, and 1/2 of 2 is 1. So dy by dx will be 3 cos 3x plus the sine of x over 2. Do you want to try and work out dy by dx for question D? You can pause the video and come back when you're ready. Okay, so I'll come back if you had a go. So the derivative of sine we know is cos. So dy by dx will be 6 times the cos of that angle x squared minus x multiplied by the derivative of the inner function of the x squared minus x. When you differentiate x squared minus x, we get 2x minus 1. So dy by dx will be 6 lots of 2x minus 1 multiplied by the cos of x squared minus x. Okay? How did you get on with that? Let's try question 2. So do you want to work through the examples in question 2? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So question A, the derivative of x will have the 8, and then the derivative of sine x we know is cos x. So 8 cos x. For question B, f prime of x, the derivative of x is just 1. For cos, we get negative sine, and then we'll multiply it by the derivative of this inner function. So we'll have plus 4 sine of 4x. For question C, f prime of x, the derivative of sine is cos, and we need to multiply it by the derivative of this inner function, which is just 2x. So we'll have 2x times the cos of x squared plus pi over 3. And for question D, I'm going to write question 3 differently. We'll say that f of x is 3 sine x squared. So I'm just writing this 2 on the outside, because I know when I differentiate this, we bring the power down, and then we take away 1 from the power. So the first part will be 6 times the sine of x to the power of 1, and then we need to multiply it by the derivative of this inner function, which is cos x. So we have 6 sine x cos x. And using the double angle formulae, we could also have written this as 3 sine 2x. But this is a perfectly valid answer as well. How did you get on with them? Let's try question 3. So in example 3, we've got an exam style question. Do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we want to work out the equation of a tangent to the curve. And we know the equation of a straight line will be m lots of x minus x1 equals y minus y1. We've been given x1 as pi over 4, and we're given y1 as 2. So all we need to do is work out m, which means we need to differentiate y with respect to x. So dy by dx, when we differentiate the 2, that goes. The derivative of cos is going to be negative sine, but we need to multiply it by the derivative of this inner function. So we'll have 4 multiplied by negative 2 sine 2x. When we differentiate the sine 4x, we get negative multiplied by the derivative of this, so negative 4. And the derivative of sine is cos. We can tidy this up, so dy by dx will be negative 8 sine 2x minus 4 cos 4x. So to work out the gradient of a tangent, we need to let x equal pi over 4, and then to substitute that into here. So at x equals pi over 4, we'll have negative 8 times the sine of double this angle, so pi over 2, minus 4 times the cos of pi. I've just multiplied this by 4. If we draw the sine graph, at pi over 2, we've got 1. So this will give us negative 8. If we sketch the cos graph, at pi, we've got negative 1. So this will give us positive 4. So the gradient will be negative 4. Substituting this into the equation of a line, we'll have negative 4 multiplied by x minus pi over 4 will equal y minus y1. We'll expand out the bracket, negative 4x plus the pi will equal y. I should have said here that this is 2 minus 2. We'll move this negative 2 over to the left-hand side. So y will equal negative 4x plus 2 plus pi. So A is negative 4 and B is positive 2. Okay? Well, thank you very much for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.